Greetings and welcome to my new calculus channel. My name is John Gabriel, and today I'm going to speak about that very well-known constant that everybody calls pi. So let's begin. So before we can answer what is pi, we need to know what is a number. So what is a number? So we realize the concept of number when we attempt to measure the antecedent of a given ratio. Okay, so if P colon Q is a ratio, P is the antecedent, and Q is the consequent. And usually we do this with a chosen magnitude. We measure P with a chosen magnitude, or a factor of both of the antecedent and the consequent parts of the ratio. But on its own, P colon Q literally means P compared to Q. Okay, that's all it means. It doesn't mean anything else. And indirectly, we are actually stating a possible proportional relationship between P and Q when we write P colon Q. We don't know that there is a relation. Why? Because we don't know if P and Q have a common divisor or a common factor, which means then that we can measure P, okay? So we do this because we want to be able to refer to the measure of P. It's P that we're measuring, okay, which is the antecedent. We want to refer to it by a name. We don't want to have to constantly write down the magnitudes, which could be lines or areas or whatever else the case might be. We want to refer to this by name. So at present, both P and Q are magnitudes. Let's say straight lines. They're definitely not numbers, okay? They're just let's say two straight lines. If the unit magnitude, excuse me, and or any other equal part of the unit divides both P and Q, then we call the measure of Q by the name P over Q, okay? P over Q is a name. It doesn't mean P divided by Q. It's the name we give to the measure of P, if they have a common divisor, or if the unit divides both of them, okay? Now, if a common magnitude cannot be found that measures or divides both P and Q, then P has no measure, meaning there is no number P over Q that describes the measure of P. So for this reason and this reason alone, we define the concept of measure through the abstract unit, not the abstract, but the abstract unit as follows. A number is a name given to a measure that describes a magnitude or size. So what is pi? Well, although pi is realized geometrically via a ratio of magnitudes, namely the circumference to the diameter, pi does not exist as a distance, any more than, let's say, the distance 1 square root 2, 5.2, 106, doesn't matter what you have, okay? Because all those are realized through the abstract measure. So those distances don't really exist in any form except as ratios. So the ratio CD is a symptom of pi. What does symptom mean? A sign. It's a sign of pi. This means that no matter what unit we choose, there is no magnitude that measures C, nor even yet a number that describes its measure. So let's just see how this works for a second. What I'm telling you is that pi is equal to the ratio of the circumference to the diameter, okay? Ratio of the circumference, the blue line, to the diameter. And as we can see, if we use that as the unit, it's approximately 3 point something, okay? And it doesn't matter where you go. Now notice that this circumference is not the same as this one. And this is what we're measuring in the ratio. We're measuring the circumference. Okay? So coming back to this, pi itself is not an actual magnitude, but it is realized as a constant in an attempted measure of C, okay? That's when we make an attempt to measure C abstractly, because notice the size of this unit here doesn't matter in the measure of the circumference. You can choose any unit diameter you like, and it'll always be, the abstract measure will always be approximately 3.14159, etc. Okay? So in actual fact, pi does not even exist as a magnitude. Okay, there is no distance that you can say is pi. You cannot draw any line, regardless of how you come up with that line, and say that is the distance that pi represents. That's just not possible. Okay, so pi is realized when a rational number approximation, in other words, a partial measure through the abstract unit whose size is irrelevant, takes place. This is what you see over here. Okay, we only realize pi when we try to measure the circumference using the diameter. All right, so it doesn't matter what unit diameter you choose. You can't measure, there is no distance pi, and you can't measure this distance because both this antecedent and this consequent have no common divisor. Not even the unit or equal parts of the unit divide both of them, which means that you cannot write pi as this blue line over this red line, because that would mean that they have a common divisor. In other words, that pi is a number, which is false. Okay, so you can't do that. What other number, what other magnitude or ratio has that property? There are many, but let's look at square root 2. Square root 2 is the ratio of the hypotenuse to either of the sides, right? So it doesn't matter what side you choose. This ratio here will always be 1.1, 1.414, something like that, okay? It doesn't really matter. And I've put 3 here because I'm just showing you that we can measure abstractly 1, 2, and 3, but we cannot abstractly measure this size here. We can only abstractly approximate it through a rational number, okay? Because the size of the unit doesn't matter. You can use any unit you like, and you will still have the same approximate measure for the hypotenuse. Okay, so the more digits you take, the closer it gets to the value of the hypotenuse, but it's never really the hypotenuse measure. There is no measure of the hypotenuse in this triangle, just as there is no measure of the circumference in this circle, okay? No measure. So I hope you've understood now what is pi and what is a number, basically, because a number is a name that we give to the measure that describes a size or a magnitude. I'll put some useful links in the details section. My name is John Gabriel, and this is a New Calculus channel. Till next time, goodbye.